what I have explained actually, this is in between two successive collision. This is one kernel, the next kernel, in between two kernel, whatever is the time for which electron is relaxed, that is relaxation time. And this distance between two successive collision is known as free path, lambda. The successive distance between the two successive collision is called free path. Free path. What is free path? You can write the definition also. What is that? Distance between two successive collision. Okay.
Yes, sir.
Now derivation part. Right. We will derive the derivation this drift velocity. Clear? So when you connect any, like if I draw here, when you connect any wire with a cell, then what is happening? This is a cell. What is happening here? Electrons, these are the kernels. Kernels are here. These are the kernels. Positive charge. It is having positive charge. Because electron, they lose one electron, so it will carry one positive charge. These are the kernels or atoms. Copper atoms. And electrons are moving. You just apply here plus, here minus, because of battery. This plus will attract this electron, but it is not in a straight direction. It will collide. Again, change its direction. Again, it is going like that. This is the direction of motion of electron. Here, it is not going straight. Because of this cell will provide what? One electric field. Because of that electric field, there is electric force on charge. In what direction? Left direction. Clear? Any doubt? Now, there will be many electrons. Clear? This is one electron. It is going to collide with this. There is one more electron that is collide with this. So, if I take at a certain instant of time, if one electron is colliding with one of the kernel like this, clear, and there is one more collision, after colliding it will lose all the energy. This electron, after colliding, it will lose all the energy in the next collision. Then again it will accelerate here. After colliding with one of the atoms or kernels, it will lose its entire energy. Then again it will move with the thermal velocity u1. Here v1. Then if I ask, if this is u1, this is v1. In the similar manner, there is one more electron. There will be many electrons. This electron is colliding. One more electron will be there. After colliding, it is moving with a initial velocity u2, thermal velocity, and finally after acceleration, it is v2. Clear? How much time here?
Yes.
Tau 1 relaxation. How much time? Relaxation time here? Tau 2. So if I ask, I'm saying what? For a particular instant of time, one electron is colliding with one electron is going for successive collision. Clear? Similar, at the same instant of time, other electrons are also going for successive collision. Clear? So every electron is having different tau 1. Tau 1, one electron is having tau 1, tau 2, tau 3. And every electron, here it is V2, here V1, here thermal velocity is U2, here U1. So what I'm saying, there are millions of electrons. I just take for a particular instant of time, what is happening, these electrons collide and do the successive collision. So I just, because I'm worried, I just want to know what is happening in successive collision. Every time the one electron is colliding to the successive collision, it loses its entire energy. Whatever energy it gained due to acceleration, due to cell, it will lose all the energy in the next collision. So first it will collide, entire energy loss, then again it will move with the thermal velocity. Because of acceleration, it will again accelerate it, then again it will lose all its energy. Again it is moving with the thermal velocity, it will again accelerate. So electron accelerate, then again its velocity zero, again it accelerate. It is, you can say, in every successive collision, the velocity will be constant. It is not like that there is acceleration and velocity will be uniform, or it is accelerated motion. It is continuous motion because there is a hindrance, there is resistance inside the wire. So this electron is not moving freely. Clear? Every electron, if I ask what is V1, V1 is for this electron U1 plus acceleration is A, tau 1, equation 1. Can I write like this? For one electron at a particular instant of time, I am just asking. Clear? In the similar manner, this electron is having V2. By the way, what is V1? V1 means velocity before striking this kernel. U1 thermal velocity, initial thermal velocity, thermal velocity. Clear? What is this V1 before striking, before going for collision with the kernel? V1 is before striking the kernel, V1 velocity. Similarly, here for this electron, it is V2 is equal to U2 plus A tau 2, equation 2. And for example, one electron is colliding like this. There is one kernel here, it is colliding, and after that, it is going like that. Here it is having U3, V3, tau 3. Here, so there will be many electrons, and every electron is having different for a particular instant of time V3. It is having V3, U3 plus A tau 3. There, did you see this? Average initially before, and similarly for all the electrons, it will be nth electron. For example, there is n electrons. For nth electron, it will be, this is the velocity. Clear?
Yes,
So
sir.
one electron is moving with to V1 thermal velocity, V1 velocity. Before striking the next collision, it is going with V1. Other electron is going for V2. Other electron is going for V3. So every electron has different V1, V2, V3. So what we will do, we will take the average. What is the average of all these velocities? Because it is not, current is not due to one electron only. It is due to all the electrons. So we will take the average of all the velocities, so that we will get what is the mean velocity of all the electrons in particular collision. Clear? So we will take the average of this. The average will be what? U1 plus U2 plus un plus A tau 1 plus tau 2 up to tau 1 divided by total number of electrons. Then V average will be what? Average velocity u1 plus u2 plus u3 un divided by n plus a tau 1 plus tau 2 tau n by n. Clear? So what
Yes,
is
sir.
this? What is the value of this? u1 plus u2 plus u3 by n. It is 0. Average thermal velocity is 0 from this equation. Clear? It is 0 plus a. This is tau average. Average. Simply we are writing tau. Clear? So Vd, this is average thermal velocity. This average is known as Vd, drift velocity. What is this? This is the velocity with which electron drift. Clear? Every
Yes,
electron
sir.
is going with this velocity. In every successive collision, all the electron is going with this much drift velocity. Vd is equal to a tau. Now what is tau a? How much electric force? Electric force is Q into E. Then F is equal to charge is having mass also. Tell me, is it having mass also? Then how much mass of charge particle into acceleration? Can I write like this? Then
Yes, sir.
acceleration will be UE by M. If I put this value here, then what I will get? Dt is equal to QE. It's a very important relation by M. Clear?
Yes, sir.
This is the vector notation. Okay, this is in vector form. Vector. So this is the velocity with which an electron is moving in a what? Inside the conductor. Clear?
Yes, sir.
If the charge on electron is minus e. So Vd will be, drift velocity will be minus E tau by m. It's a very important relation. Drift velocity. What is this? This is the drift velocity. Clear?
Yes, sir.
What is the meaning of that? Drift velocity. For example, this is one kernel. This is next kernel. If I ask if the distance between two kernels is lambda mean. What is lambda mean? Average mean free path. Lambda 1 plus lambda 2. Because every electron is having different lambda. Clear?
Yes, sir.
This is mean free path. This is chemistry also you will learn this is mean free path. So what is the mean average in every kernel? What is the average path? Lambda m. If the average path in between two kernel is lambda m, then how much time an electron will take in order to move from one kernel to another kernel? Then simply if I keep after collision this electron, it will move up to here. How much time? Time will be distance by speed. How much? Vd. Clear? This electron is moving with drift velocity, which is the average velocity. Clear? Understood?
Yes, sir.
This is the magnitude simply. Okay. Any doubt?
No, sir.
So if you have any doubt, by the way, this is not T. This is the tau average.
Yes, sir.
Already I have explained. Tau average mean mean time, because I have taken here mean length. Time will be mean time. Every electron, first electron is taking tau 1 time. Relax, it is going to relax for tau 1. Next electron is going for tau 2 relaxation time. Another electron is going for tau 3 relaxation time. Then I will take the average of all the three. So all the electrons, if they are doing successive collision, they are moving with drift velocity Vd, and they have a mean free path lambda m, and they have the average relaxation time is lambda average. You can write simply lambda. No need to write average also. Lambda. This is the average path. One call is coming. Hello. Yes, ma'am. Here,
Yes, sir.
my question is, listen, very, very important question. This is many kernels. Many kernels are inside the atom, inside the conductor. This conductor, many electrons, like this. When you apply cell, clear, many kernels were here. Kernel, these are the positive ions. These are the atoms. Every in between successive collision, many electrons will be here. There will be many electrons. Here, some are here, some are here. Many millions of electrons, and every electron has different history, different tau. So we take average. Every electron has different path, free path. So I just take average, because anyway we need an average. How we will find what is the drift velocity? Clear? Is it clear?
Yes, sir.
Is it clear to you?
Yes, sir. It's clear.
Now this electron, for example, it is going, all the electrons, they are not moving straight. They are colliding, and finally it is going like this. Then it is going like this. Understood?
Yes,
Like
sir.
this way, electron, every electron is going like this. They are not physically collide, but they are colliding like this. Every electron is going like this. Clear? So this is the beginning of this chapter, and drift velocity is very important, because drift velocity, if you understand, means you can understand all the things. Now, for example, what is the expression of drift velocity? Sorry, Vd is equal to, for electron, it is minus E formula tau by m. What is tau? It is average
Time.
relaxation time. What is drift velocity? It is the average of velocity of electrons. What is m? M is the mass of charged particle. Here, what is E? E is the electric field. Here,
Yes, sir.
So if I ask, for example, one question, if this is the wire and length of this wire is L, and the electron, because of potential drop, electron is going like this because electric field is there, because I already told, if there is electric field there is a potential. Clear? Due to cell,
Yes, sir.
the cell is having voltage plus minus voltage drop V or terminal voltage V. This entire voltage is going to apply across this. Because of this voltage only, it is able to, this electron is able to move in a particular direction. Then only you will get net rate of flow of charge. If I ask, what is the relation between electric field and voltage? Electric field relation between E and, clear? Then you just tell me, write down the relation. It is very important. Delta V is equal to E dot, dot product,
Yes, sir.
dr is the small displacement of the charged particle. What is E? E is the electric field. What is delta V? Final potential minus initial potential. This formula is very important. I will explain. You just see here, this electron is going to displace here to here. Then initial position, final position. This is dr. Clear?
Yes, sir.
And electric field is this. Then how much delta V will be? You can say it is, I think, dr. Dr, just correct this. It is not delta V, it is dV. Correct this. It is not delta V because I take dr, small dr. Then potential will be dV only. Clear? And rub this. First, please rub this. I will explain. Wait. Okay, wait. Wait. What is happening? Little bit correction I required. See, this dV equal E dot dr. And please don't write this. Don't write this now.
Yes, sir.
I will explain. You just tell me dV equal how much? E dot dr. E dot dr. What is the angle between electric field and displacement vector? Tell me. What is the angle? 180. dr is this. Electric field is this. Electron is going like this now. In this manner. Then dV will be what? Minus E dr. This is the small voltage drop. dV. Clear? Or one simple direct formula I'm telling, delta V is equal to E into D. This is what is E? E is constant electric field. Constant. Class 12 you will learn. But remember this formula, remember. Constant electric. What is delta V? Potential drop across the conductor. Understood?
Yes, sir.
This formula. Class 12th you will learn, but I am explaining. This is very, very important. What is D? D is the distance between the two ends of a conductor. Distance between the two ends of a conductor. Now you just tell me, if my wire is this is the wire. If I ask you, if this is a cell, current is going like this. Current is going like this. Then which is A is here, B is here. A is at high potential or B is at high potential?
Yes, at high potential.
Very nice. Current always flows from high potential to low potential.
High
Electron will be
potential to
here.
low potential.
Electron will be here. Now, high delta V is equal to E into T. Then always, how much voltage drop? How much? From A to B, delta V will be, tell me, what is that?
Minus CED.
Always higher minus lower. So E will be how much? Voltage drop, that is V, D is L. Clear?
Yes, sir.
Length is L. Length of the conductor is L. Then delta V will be E into D. E will be what? V by L. This entire voltage is going to drop across A and B. This formula, simply this VD, then VD formula is what? Minus E tau by L. Here,
Yes, sir.
any doubt?
No, sir.
If you have any doubt, please ask me. Okay. Or
No
I
doubt,
think
sir.
wait, just a minute. It that's wait. Yes. Wait. Wait. Give me 1 minute. Okay, I will share. Wait, 1 minute. Is my screen visible?
Yes, sir.
Okay. Just see here. Here minus V will be there. Why minus V? Because potential is going to drop. Delta V means final minus initial. VB minus VA. So it will be negative. So already negative here. So VD will be E V by ml tau. If I ask simply the magnitude, it will be like that only. Clear?
Yes, sir.
Even if you want like this, just see here. This is a vector form. If I ask simply magnitude, it will be minus E tau by m. So what is E? E will be minus V by L tau by m. Across the conductor, in terms of voltage, VD will be EV by ml. Very, very important relation I am going to find now. It's very, very important. Now one relation is I will derive also. Just remember now only I is equal to N EAVD. Equation 1. What is N? Number of free electrons. Number of free electrons per unit volume. Clear?
Yes, sir.
A is the area of cross section. What is VD? VD is the drift velocity. From here, what is the value of VD? You just tell me what is the value of VD. If I ask I is equal to NEAVD, NEAVD, VD will be EV tau by ml. So can I write like this? R is equal to A by ml square, ml by NE square tau. Can I write like this?
Yes, sir.
ml by NE square tau. Can I write? So you will see what is A is the area of cross section. I think voltage is remaining now. Wait. I is equal to AV. V is here. I forget to write. So what it is now? ML square, ML NE square. What is that? I just replace I is equal to NEAVD. So VD will be EE tau by M. EE. I simply write NEAVD. E tau by M. E is replaced V by L. Clear? What you will get? Area into voltage NE square tau by ml. ml by NE square tau. Can I write like this? Any doubt?
No,
You
sir.
just tell me any doubt. So if you look at that ml by NE square, you just keep it here and 1 upon A. This is V by I. And if I keep this here, M by NE square tau L by A. Very, very important relation. What is this B by I? Ohm's law. As per Ohm's law, V by I will be R. What is this whole term? Resistivity, rho. R is equal to What is that? Actually, this is R. Clear?
Yes, sir.
And this value of R will be how much? R is what? ml by ne square tau A. This is the value of R. This is resistance. Now you just tell me if temperature and pressure is constant. This is LHS. If temperature and pressure T is constant, pressure is constant, then you just tell me will N A is constant because area of cross section never change, T is constant, P is constant, length never change, mass never change, tau. Relaxation time depends on temperature. If more temperature, lesser is the relaxation time. So neither N is changing, E is changing. E is the charge on electron, N is the number of electrons free per unit volume. If you change the material, then only it will change. We are not changing the material. So this M is constant, L is constant, N is constant, E is constant, tau is constant. Clear? Then LHS is continuously constant. Constant is equal to, if I write here, what is that? Constant is equal to V by I. Can I write this V proportional to I? Can I
Yes,
write?
sir.
At, you have learned like at constant temperature and pressure, V proportional to I. It is coming from here, this equation. There, and when you remove this proportionality sign, it term constant is come, that is resistance R. Value of this R is what? I have written here ml by n square tau A. This whole term. ml by n square tau A. Clear? Any doubt?
No, sir.
I think one in this chapter, na many units, many equations were there. Clear?
Yes, sir.
So R, what is a V is equal to IR. So what is the value of R? R is ml by n square tau A. You can check. R, value of R will be I ask m by n square tau L by A. If I compare, what is this? This is resistivity. So what is the formula? R is equal to rho L by A. I think you have learned this.
Yes, sir.
Rho is what? M by resistivity is M n n square tau. And I think this is being taught to you like resistivity depends on material. Why it is depending on material? See here. Resistivity M is the mass of an atom. Here, mass of an charged particle. N is number of free electrons per unit volume. It depends on material. It is N is a property of material. E remain constant. E never change. M never change because mass can neither be created nor be destroyed. If the material is same, for example, this is made up of copper. If this is made up of copper, then N is fixed. Number of free electrons per unit volume is fixed here. M is also fixed. M is also fixed here. N is fixed, M is fixed, E is fixed. And temperature pressure is constant, then tau is also constant. Then rho is constant. This is what we have learned. Rho is the resistivity. It is also constant. It is constant. Why? If temperature is constant, then only we say resistivity does not change. Resistivity does not depend on length. Again, I am saying length and area. You can see the formula. For conductors, the resistivity does not depend on L and A. If you increase the value of tau, then resistivity decrease. This question they can ask. If you increase the value of N, By changing the material, then resistivity decrease. Clear? Is it clear or not?
Yes.
So
Sir, can you
resistivity,
explain this?
which one?
Resistivity.
Resistivity. So resistivity means what? Wait. Yes. Resistivity means this rho. Have you seen this formula rho?
Yes, sir.
M by, again see, N E square tau. This is, what is rho? This rho is resistivity. Resistivity. And this depends on temperature. Tau depends on temperature. E never change charge on electron. N depends on material. N depends on material. Mass never change. Mass of particle is same. Electron is same now. So rho is inversely to the, in M is constant, E is constant, N tau. If I keep material same, then N is also constant. It depends on material now. If you take copper has different number of free electrons per unit volume. Small n means number of free electrons per unit volume. Clear? You can switch on the video. Actually, I'm not able to understand whether you're understanding or not.
No, sir. Actually, I was having internet issues, so I thought
Okay. So
couldn't get
understood now.
disrupted. Yes, sir.
Small n depends on material. If you take silver, then it is having a different n. If you take copper, it has different n. If you take aluminum, it has different n. So that is why resistivity depends on material. It is a property of material. Resistivity it is a property of material. You can write also, because from the formula itself you can tell it is a property of material. Material. And tau depends on temperature. The average relaxation time. If you increase the temperature, collisions are frequent, very rapidly. So in between two successive collision, tau will be less. If tau is less, then resistivity increase. Clear? Resistivity
Yes.
increase if tau decreases. Clear?
Yes, sir.
If tau increases, then resistivity increases. Clear?
Yes, sir.
So this rho is inversely to the n tau. Now what is conductivity? Sigma is equal to 1 upon reciprocal of resistivity. This is electrical conductivity. Sigma is electrical. This question in 1 mark they are asking. If rho is more, then sigma is less or more. Electrical conductivity. Reciprocal of resistivity. Clear? Similarly, G is equal to 1 upon R. What is that? G is conductance. Reciprocal of resistance. Conductance. Understood?
Yes, sir. Understood.
Now you just see what is the formula we get for R? ml by n square tau A. R is ml by n square tau A. R is ml by n square tau A. Please tell me here what is constant. If I am not changing the material, if I take only copper, I take copper wire. Then what is constant? Mass is constant. N is also constant. For example, 10 to the power 29 electrons per meter cube. Mass is also constant. Temperature is constant. Sorry, length is constant. Area is constant. Then can I say L is constant, A is constant, N is constant, E is constant, M is constant. So resistance
Yes.
inversely to the tau.
Tau.
Then if I increase the temperature, then tau decrease. If tau
Decrease.
decrease, R increase. This is what we have learned. Resistance of a conductor increase with increase in temperature. And reason they have told it enquired frequent number of collision will increase. Collision increase means less relaxation time. It has less time to relax. This is what you have learned for metal. This R increase will increase in temperature because in your course metal only there. And this resistance we will learn later. This formula you should very important. You should learn this formula. R is equal to ml by n square tau a. This is the way you should learn. B is equal to IR. Everyone learn this. B is equal to IR, but it is that no one learn what is this R, from where this R came. R value is what? ml by n square tau a. ml by
By
n square tau a. And what is rho? Rho is m by n square. These two terms you must remember. Many questions they can ask. For if you increase the time relaxation time, what is the effect on resistivity? If you increase the area of cross section, then do you find any change in the resistivity? No, because resistivity does not depend on A. Clear?
yes,
If you
sir.
change the length, resistivity never change. But if you change the temperature, then resistivity and resistance both vary. If you change the material, resistivity vary, yes. If you change the material, resistance vary, yes. Clear?
Sir, for the formula R, can we replace ml by n square tau by rho?
Yeah. For m by not ml, it is m by n square tau. You can replace m by n square tau here. This m by n square tau by rho L by A. Like this is formula. This formula you have learned. Here R is equal to rho L by. But you must know what
Sir,
is
your
the
voice
meaning.
is not audible, sir.
I'm saying use formula you have learned. R is equal to rho L by A. Clear? Am I audible? Hello.
Yes, sir, now it's audible.
Actually, I'm saying this formula R is equal to rho L by A. You have learned. But
Yes, sir.
you should know what is rho. What is a rho means? Rho is resistivity, and resistivity formula is m by n square tau. Clear? If they can ask if I change the L and A, length and area, do you find any change in resistivity? No. They can ask if temperature is constant, then if I increase the length of the conductor, do you find any change in resistivity? No, because rho is
No,
m by n square tau. If you change the material, then only it will change. Here, so I will stop the lecture today. Tomorrow I will this I is equal to NEAVD. This derivation I told now. I will explain that also.
yes,
Relation,
sir.
how this relation came. Now you understand from where this Ohm's law came.
Yes, sir, I understand.
This is the concept. All electrons, because of this cell, one electric field generated. Because of this electric field, electrons are not moving on a straight path. It is collide, again going straight, collide, again going straight, collide. So it is moving like that, like that. And finally, and they are moving with a drift velocity. In the inside, it is not moving very fast. Here, and you should understand this electric field is moving with a speed of light. As soon as cell is connected to a appliance is connected to a cell, suddenly electric field reaches to ends of conductor. Clear?
Yes, sir.
Suddenly potential is applied across the conductor and you will see the current. Clear?
Yes, sir.
So ordered motion of the electron is only because of potential. If there is no potential, they will not move in the ordered way. You will see zero current. But because of cell, battery, because of this EMF, this cell voltage, they are moving in an ordered manner, and you are watching some current. So okay, I will stop the lecture now only. This current is very important. I think this is clear how resistance came. Many questions they can
Yes, sir.
ask. For conductor, this formula only you should remember. After that, tomorrow I will explain series, parallel, resistance. Very important topic tomorrow also. Not tomorrow, I will take day after. There. So
Yes,
till
sir.
today, please revise all the things. And if you have any doubt, okay, bye.
Yes.
I will stop
Thank you,
here.
sir.
Good night. Good night.
Thank you, sir.